Explaining the pathophysiology of many conditions you will learn about in nursing school, part 3, neurogenic shock. Y'all really wanted the shock, so we're gonna learn them. Let's start with a breakdown of our autonomic nervous system, the involuntary portion of our nervous system. I like to think of it as automatic. It's happening in our body without our control. The system is further broken down into parasympathetic, rest and digest, and sympathetic, fight or flight systems, which work like a light switch. When one is on, the other is off, and vice versa. For the purpose of neurogenic shock, we are going to focus on the sympathetic nervous system. Ready? Okay, here we go. Normally, the brain communicates with the sympathetic nervous system through descending spinal pathways. These pathways transmit signals from the hypothalamus and brainstem to the sympathetic neurons located in the middle to lower spinal cord. This area of the spinal cord has a name. I'm not even going to try to pronounce it. Here it is. And this area is going to be important for later, so remember it. The SNS is our fight or flight response. When activated, it releases norepinephrine onto target organs, basically every organ in our body, and causes vasoconstriction. Okay, now that we have that covered, we set the stage for neurogenic shock. When damage occurs to the brain or spinal cord at or above the level of T6, these communication pathways are disrupted. And if those pathways are disrupted, the CNS, our brain and spinal cord, can no longer send signals to those sympathetic neurons. So norepinephrine isn't released and our sympathetic fight or flight response fails. And as a result, the loss of sympathetic tone allows the parasympathetic system to take lead, and that switch now activates. Rest and digest activity dominates, leading to the characteristic hypotension and bradycardia seen in neurogenic shock. Now, all of that patho happens minutes to hours after the injury, and this loss of sympathetic tone is a life-threatening hemodynamic problem. Then, in the stabilized phase, we look at long-term deficits, depending on how severely damaged the spinal cord was. And that is all.